Okay, in this video I'm just going to show you an example of using a break statement and how break works. Now, if you'll notice, first of all, just like in class, we have some nesting in this code because you have a loop right here. And so the loop, remember, is repetition. It's going to repeat, 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 and one of the things that it's going to repeat, you have an if statement nested inside your for. So one of the things it's going to repeat is making a decision. So repeatedly, one of the things you're going to do is make a decision. Now, this right here, this break, is a loop killer. And so he would murder your loop. Don't forget, your loop will die of old age eventually. Eventually, he would just reach the end of his lifetime and die. But in the event, like this right here, this if statement, think about like this as the room where the murderer is. So this loop, this thing that could kill your loop before it's done, that's only going to happen in the event that you get into this if statement. So if you enter into the room with the killer, if you can get into the if statement, then this break will cause this loop to die early. Now, what do I mean for it to end early? Take a look at this for loop. This for loop has a natural lifetime. It will eventually end on its own. I'm going to change it. I like that better, actually. Okay, so let's say this. Don't forget, we get these variables, xmin, xmax. So this, I'm going to get psychic with this for loop. I'm not even going to worry about what's in the loop or what it does. I'm just going to look at the lifetime of the loop right here. All the information I didn't need to know about how long the loop would like to live under natural causes is right here. First of all, x will start his life at 0. So I'm going to say, okay, he'd like to start at 0. Now, x is going to be going up by 1, so he's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. When x becomes 9, 9 is still less than or equal to the max, so it would come through the loop. X will become 10. When x becomes 10, 10 is still less than or equal to the max because it's equal to it. So the 10 would let you into the loop. Then when x becomes 11, that will kick you out. So this loop right here under natural causes would like to run for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then he would die of old age on his own terms. Now, we haven't even looked to see what it's going to do or what it would do in the loop, but we just know that that's what would happen with x. So let's start to trace this. X is 0, 0 is less than or equal to 10, which lets us come right here. So y would be 2 times 0 minus 10, negative 10. And it would print out an ordered pair, 0, comma, negative 10. Now, then, here comes the decision. Is y currently equal to negative 10? Or, sorry, is y currently equal to 0? No. Since it is not 0, I will not come into the room with the killer. I'm not going to come into this if statement. I skip, so I print. This is false. I come to the bottom of the for, which sends me back here. X becomes 1. 1 still less than or equal to 10, and so this gives me negative 8, which is still not 0. I will print out 1 comma negative 8. That's not 0, so I will skip the if statement, come to the bottom of the for, come back, it becomes 2. When x is 2, lets me into the loop. So it's following this pattern that we expected. It's going to do this. Still not 0, so I can't do that. Come back around, becomes 3. When it is 3, I'm going to have 2 times 3 minus 10 gives me negative 4. And then repeatedly I'm trying to make a decision. That is false. So I'm going to skip the if, come back around. Negative 2. That's not 0. X becomes 5. Now, 2 times 5 is 10. 10 minus 10 is 0. So when x is 5, 5 comes into the loop, that happens, I'm going to print out 5, 0. Now, y in this exact moment is 0. Now here's where something bizarre happens, because this is 0. That will finally let me into this if statement. I've skipped this if statement every single time. I've never gotten into the room with the loop killer. Now this is true. I'll print out found a 0 in all capital letters, and then I will touch this break statement, and this break statement will kill the loop. Now don't forget, an if is not a loop, so if the break does not kill the if, this break will cause this loop right here to end early. And so now think about this. We predicted that the loop was going to run all the way up to 10 and then die of old age, but what just happened is, because you got into the room with the loop killer, this for loop just died, and he did not get to live his entire lifetime. Now, you've printed found a 0, you broke the loop, kicks you out of this loop, and you would simply print the end. So, the output that you're going to see is going to be just a bunch of ordered pairs. Well, if I can, let me show you this output. So the output you're going to see is x was 0, it printed the ordered pair, x was 1, it printed the ordered pair, boom, 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 prints ordered pair, prints ordered pair. When it was 0, when x was 5, y was 0, you printed that ordered pair, you got into the if statement that printed found a 0, and then you kicked immediately to the end. So lots of ordered pairs, found a 0, kicks to the end. And that's how a break statement could kill the loop. Now, every loop does not need a break statement, so please don't put a break statement in every loop. Every loop will die of old age eventually, and just because there's a break statement in the loop doesn't mean it's going to actually happen. So for example, if I said that this thing, if I change this program and I say that the x min is 6 and the x max is 10, then that means, let's change my game here, that means this x loop would start at 6 and say 6, 7, 8, 9, 10. And then after x becomes 10, it gets in for 10, it does not get in for 11, and it would kick out. So this loop would like to run this entire lifetime. This would be his lifetime, is what he would like to do, and then die of old age. And what's going to happen is, when x is 6, 12 minus 10 is 2. 14 minus 10 is 4. And then 16, 2 times 8 minus 10 is 6. 8, 10, and so every one of these, you're repeating that decision. The decision you make every single time is y is not 0, so you skip the break. So if you were to run this, you're never going to break, you won't break the loop early. The loop will just eventually end on its own terms, and you won't say found a 0 and break the loop. So just know that this break statement doesn't always kill somebody. You have to get into this room with him. If you get into the room with the killer, then the loop will be killed early. And that's how a break statement works.